A monument is in the shape of frustum of a square pyramid of base side 6 meters and top side of 3 meters with a height of 6 meters. An electrical connection given from the midpoint of base edge to the midpoint of top edge on opposite side. Find the smallest length of the wire to make the electrical connections and show it in projection. So what is asking here? A monument has reached there, so which is in the shape of a frustum of the square pyramid. So on the beginning of the solids we are discussing the frustum is nothing but a section of solid, so which cuts parallel to its base. Other than parallel, that is the truncated. So first try to understand what has been given here. So for that one, before moving to that one, so roughly I will explain so what the question has been asking here. So it is a frustum of the square pyramid. So that means the base we are having a square. At certain height we are having top also a square. So now this is in this frustum. So what is asking? An electrical connection is made from where to where? From the midpoint of the base. If you are observing here, so this is the midpoint, let us assume. From this, an electrical connection is giving from the midpoint of the base edge to the top side of the midpoint. But where it is on opposite side. This is of same side, so this is the opposite side. From this point to this point, electrical connection is giving. So how that is there? So over the surface, if it is giving, so what is the shortest, that is the smallest length of the wire required to make the connection? At the same time, he is asking, is interested to show in the front view and top view also. So that means the wire is coming here and just it is passing over this one. So here you are not able to view. So like this when it is coming. So this you want to know the length. At the same time, you want to show in the projections also. So for that one, so even it is not asking nowhere to develop the surface. So wherever getting the shortest, compulsory you have to apply the technique of development of the surface. So now before the one more thing you have to consider here. The dimensions has been given. Here is the 6 meters and again here is the 3 meters. Again here is the 6 meters. Are able to draw the meters on the drawing sheet? It is not possible. In such case you have to just make yourself a proportional references. Instead of the meters, if it is possible to represent the centimeters, it is okay. So that means what the proportion? Instead of the meters, I am reducing the centimeters mean. So 1 meter equals to 100 centimeters. So that by applying a scale of 1:100, all the meters becomes into the centimeters. So for every solution, wherever the practical dimensions you are conveniently you are reducing, you have to compulsory mention the such relation how much you are applying for the scale. So now we will start the solution for how to find the smallest length. So for that one, you have to remember the information required to draw the solution. So now remaining the first one is the solid solution. Solid is a frustum of the square pyramid which having the base edge of 6 meters and top edge of 3 meters and height of the 6 meters. So after that, so one more thing you have to keep in mind, electrical connection was made from midpoint of the base edge to the midpoint of the top edge on the opposite side. If you keep remember, you can solve the problem. The first step, you have to draw the reference line here. I draw the reference line. So after that, since the base edge is the 6 meter, so before moving, you have to just apply and you have to write a note. So what the note to be written here? Note by applying a scale of. You have to write the note by applying a scale of 1:100. So then what the dimensions we are having? 6 meters we are having. So 6 meters becomes as 6 centimeters. And one more dimension we are having, that is the 3 meters. The 3 meters becomes 3 centimeters. So once you understand the reduced dimension, as per that you have to move for construction. The first side has been given as the 6 centimeters. So draw the base edge of 6 centimeters. Since it is a square, draw perpendicularly 6 centimeters and draw perpendicularly 6 centimeters. They simply close the side here. Okay. How many corners we are having? 4. Let A, B, C, If it is a prism, you can allow this is right, but we are having is a pyramid. Pyramid means every slant edge is sloped towards the apex. The apex is nothing but in even numbers of side we can find by drawing the diagonals. So let I draw the diagonal. So for that one, take the scale and simply draw the diagonal. Take the scale, draw the diagonal, and opposite other diagonals also you can draw here. So now this is the apex here. The apex can be labeled as O. Now corresponding other view to be drawn by projecting into the front view. Now since apex need to be found along the axis, I am drawing the axis reference here. Now on other end, draw. So now locate the points required here. So since it is A, this point is A dash, this point is B dash, invisible is C dash, invisible is D dash, and O dash should be located if you know the apex, if you know the height, but height are not known. But instead of that, what is the known here? So the known is here at a height of 6 meters, the top edge is of 3 meters. As we are conveniently reducing, so these dimensions are appear instead of the 6 meters, 6 centimeters. So now the height required of the 6 meters, so I can represent as a 6 centimeters. At the 6 centimeters, so what having a length, the top edge is of 3 meters. So along the midline, it should be distributed equally on either side. At the top, we are having the 3 meters equally distributed. So 1.5 to 1.5. So this represents. So whereas the bottom we are having. So let I complete the respective figure by adding the slant edges. So now since we are having the two edges here also two edges. So which I can represent as P dash, Q dash, R dash and S dash. The same thing you have to project back onto the top view. We know that front view top view lay same line. So let I complete the top side part. So now connect with respect to. So now we are taken here. So now coming to the what the question has given. So from the midpoint here, locate the midpoint here also. So what the midpoint in it? I am making the connection midpoint of the base edge. So midpoint of the base edge here. From here, where I am locating? So midpoint of the top edge. So let I want to represent here. So this I can label as this point, let M1. This point I am locating M2. Respect to this point is M1 dash. The respect to this point, the being behind, it is not visible. In brackets I am giving M2 dash. An electrical connection was made. Is asking from here to here in the shortest, that is the smallest length. So for the smallest length, the compulsory you have to develop the view so that I can from the respective point to point 2, I measure the shortest as a straight line length. So that can be the answer for that one. So now I need to develop the surface for the respective frustum. So for that one, what I need, so since it is a pyramid, I have to apply the radial line method. So just proceed for that one. I need the radius how much to be drawn. So for the radius, I need the slant length to be measured. For the slant length to be measured, I need to find the apex. So in this one, directly apex is not given. So find the apex. How the apex can be found? So indirectly, you have to just extend the slant slopes. Similarly, from other end, extend the slant slope where they met. So that is nothing but apex. So this point is the apex point which having the O dash. To represent with an ink, I can just make it here. So this is the apex. So now measure the length that could be used for this one. So this also before measuring, you have to check one more thing. So what's the one more thing? On the developed surface, everything must be true length. How can find the true length condition? You have to check the respective we are measuring in the front view mean it must be parallel to VP. So where you get the details of VP? In the top view. Now observe here either OA, OB, OC, OD. So no one is parallel to XY line. Since no one is making XY line parallel, the respective are there is no choice of getting the true length. So in that case, what you have to take? Assumption. So what is the assumption? You have to forcefully make one of the slant edge parallel. For that one, so let it make one of the side parallel. Forcefully making parallel. So for that, from the center of the top view apex, draw a straight line. After that, take the compass. Now any slant length distance has the radius. Any slant length distance has the radius. You have to draw the arc such that you are forcefully making. So that means, this point where it made, I can just label as the B1. I can transfer the B1 point respectively to the front view location. So this distance, this point is nothing but B1 dash. If you measure the distance B1 dash to the apex, so that will be the true length here. This true length has to be used for our development of surface. That seems as a simple question. So this many logics you have to understand while proceeding. Only the fundamental concept in developed surface, every measurement must be true length. So that's why for that you have to just take the consideration of these things. If it is parallel, so then only you can measure that length. If you are not parallel, make them forcefully to parallel and respect to the temporary location position, measure the distance. So now this will be. In the new location, I am just taking any particular point as a reference. Take the compass, measure the length here to here. This much length as the radius. I can draw primarily a blind arc. After that, with the help of the scale, I draw primary side first. I am drawing a primary side here. This is the primary side drawn. So let us assume this is the O and this is the E. From here, the distance is how much ledge length is there, how many edges we are having, 4 edges. All the 4 edges to be transferred along the circumference to get the other slant edges. For that, take the compass, take the radius equal to the side length here. This is the starting point. Draw the arc here. Again, intersection point at the center. Second one. Again here. Third one. Again from there. Fourth one. So now label them accordingly here. Since that is a, this point is of B, this point is of C, and it is a D, and again starting point is the A. So after that, with the help of the normal scale, you can connect every point with respect to apex. Clear? You have to connect all the points respectively. At the end points you can observe here, it seems as a curved point, but we are having the straight edges. So that you can make every corresponding edge as a straight edge. With the scale, you can connect them end to end by the straight lines. Okay, you can connect them every point end to end as a straight line. But now it is representing complete pyramid. But what we know as per the given, for the frustum development, instead of the complete OA, I have the partial edges only. But one advantage, being we are intersected, that is the frustum, every slant edge is, so that's why all the dimension we are aware, all the dimension must be true dimension. So for that consideration, I have to transfer this PQRS all are onto the true length. Once you are getting onto the true length, measure the distance around the true length only with the help of the compass. So now from this O as the center, you have to draw the arc to intersect each edge. Such that I am getting the respective point. So now I can just label them as a point. This point is the P, this point is Q, this point is R, this point is S, and this point will be again P. After that, we know that all the edges are straight edges with the normal scale, with the simple take the scale and connect them everything accordingly. P to Q. So make the outer edges a little dark. So being whatever the outline will be developed surface of the required frustum of the pyramid. So now coming to our question. So what the question has been given here, midpoint of the point. Already we located the midpoint. So where the midpoint has been here now? Here the midpoint is in between AB. Here is the AB. You have to locate the midpoint here. Since it is of 6, the location is the midpoint. So this point is represented as M1. Where is the M2? M2 is the midpoint of, set I will label here, P, Q, R, S. Midpoint of R and S. So midpoint of R is that is here. So you have to consider the midpoint here, 1.5. So this will be midpoint 2. So now I need the shortest distance between the point is nothing but just a short straight line. This is nothing but a straight line to be connected. Connect with the straight line and you can measure the length. So that will be the solution. So you can measure the length here to here. From this midpoint to this midpoint, I can transfer back onto the scaled dimension. It is nothing but. So what is the 10.5? So 10.5 centimeters. If I multiply back with 100, so what is the smallest length of the wire? 10.5 meters. The smallest wire length required. Required is 10.5 meters. Don't forget, you are measured is centimeters only, but already we are scaled down 100. You want to represent the solution, you have to again scale up. By multiplying 100, instead of the centimeters, I will get 10.5 meters. So after that, the one more thing, you want to show the same dimension here also. So while showing, so how the dimension to be taken, M1, M2 is fixed. So what that it is leaning, while traveling this one, on the edge of this OB, it is leaning here. So let us assume K point. On the edge of the OC, it is leaning at this point. Let us assume this is the L. To show the same thing, it will be transferred back. From this view, it has to be transferred back. So for that one, again take the compass. So measure the distance O to K. It has to be transferred not directly onto the OB. Why? Because it is a 2 dimension, it is a projected dimension. So that's why transfer on first onto the correct location. This is the K. Next L also to be measured. I am measuring L. L is on OC, but directly it cannot be transferred directly to OC. I am transferring first onto the true length. So where is the true length here? And mark the corresponding point here. So this is the true length. This is the L. So now mark the same thing how it is moving here. M1 to K, K to L, L to M2 it is moving. So let I consider same with the help of M1 to K. So it should be actually taken back to the original location. So where is the K? K should be on the edge. Where the on edge? OB. Where is the OB? Here is the OB. So it should be getting back. So where is the L actually? On OC. He should be getting back here. So now locate the points. So this point is nothing but K dash. This point is nothing but L dash. How it has to be moved? The same I show with the help of the scale connection. So now M1, K, L, M2 all are the straight edges. So that means M1 to K it has to move. So in this case M1 to K is here. So I have to connect by the straight line here. Here to here is the straight line. After that it has to pass from K to L. So where is the K dash and L dash? Along the same edge it appears. So this is the K to L. From L it is moving to M. But from the L it is moving to the hidden. So whenever the hidden it moves, it should be represented as a dash line. It should be represented as dash line. So this is in our which view? Front view. The same thing to be shown in the top view also. For that, use the projector. K dash has to be transferred onto the respective K and L dash has to be transferred onto the respective H here. So now coming to here. So this is the point of K and this is the point of L. Now the same procedure you have to follow by the straight lines. M to K. From here passing K to L. Again from L to M2 it is getting. This is in the top. So very clearly and carefully you have to do this one. So now as per the given, monument of base 6 meters and the top edge of 3 meters with a height of 6 meters. Made electrical connection from midpoint of the base to the top side opposite midpoint, making electrical connection midpoint to midpoint. So find the smallest length and show in the projection. I am finding the smallest length of the 10.5 meters required, and after that I am showing the same thing in our solution. This is the front view path and this is the top view path. So just by adding the dimension I can conclude this solution. Clear? I can just add the dimension line here. Add the arrowheads here. So what the height? Since it is the meters, you can add 6 meters. It is of also base 6 meters, right? 6 meters and square. Here it is a square of 3 meters and the 3 meters. So like that you have to complete the solution. So with this, the topic of development of surfaces we can complete. Please keep in mind everywhere. So just to understand the development of the surface, a simple logic, you should have the prior knowledge of the solids as well as the planes. It is nothing but we are adding the solid sometimes to get the planes, we are interacting the planes. After that you are developing, that means unfolding the lateral surfaces most of the times. By neat representation, by following the good dimensioning principle, we are able to prepare good drawings